Hi, and welcome to Geometry Pre-AP. Today we're going to learn about trigonometry in our class and learn how to recognize sine, cosine, and tangent, and how to do trigonometric ratios and solve problems involving those. We'll start our lesson with two simple slides here. We have to understand and grasp these first couple slides. If we can't determine what is the opposite leg and the adjacent leg and the hypotenuse in a right triangle to an angle, then we can't really do trig very well. So these two slides are very important. So here's our first one. Which side is the hypotenuse of this triangle? And so we know if we have the right angle, across from the right angle is the hypotenuse. So we have side AC. What is the leg opposite of angle A? So here's angle A. And one of the ways I try to remember what is the side opposite is this. Imagine if we had a spray bottle and we were spraying across from angle A, and the spray would come across and it'd hit this opposite side. So the opposite leg of angle A would be BC, and then the adjacent leg would be the leg that's next to our angle, not the hypotenuse, the leg, and that would be AB. All right, and so these are the key concepts, because in trig we will change the angle we're looking at and look at different angles, and we'll need to be able to determine which is the leg opposite, which is the leg adjacent, which is the hypotenuse, and that will change in all of our problems as we move along. So here's another little example. Pause the video and answer the questions at this time. Alright, so now that you've restarted the video again, we look again at the leg, or here we're looking for the hypotenuse, so we go across from the right angle, and the hypotenuse here is AC. The leg opposite of angle C, remember our spray bottle, we spray across to here, and it hits that side that is the opposite. We have changed our angle in this problem, so it's now side AB is the opposite leg, and the adjacent leg will be the leg that's right next to the angle, not the hypotenuse. If you can get these concepts down, trig will be very easy to do. Alright, so just a little information for you about where trig comes from. The word trigonometry comes from the Greeks, having the word trigon, which means triangles, and metry, which is about measures. So it's about the measures of triangles. And the trigonometric ratio is the ratio of the lengths of the sides of a right triangle. Remember that the word ratio is a fraction. One number over another. So it's comparison of two different numbers. And we're going to do this for right triangles. Remember that we did this same thing back in our last unit where we did the geometric mean, or we did the altitude to the hypotenuse, and there were ratios there also. Alright, so our trig functions here. You'll want to write these down. First, we have the sine of an angle is equal to the opposite leg of an angle over the hypotenuse. And here is a short abbreviation for that setup. Then we have the cosine of an angle is equal to the adjacent leg of an angle over the hypotenuse. And we have a little formula set up right here. And then we have the tangent of an angle equals the leg opposite of an angle over the adjacent leg of the angle. And here's a simple little abbreviated formula for you. Tangent of the angle equals O over A. Remember that the O, the H, the A, the H, the O, and the A all stand for opposite leg, hypotenuse, adjacent leg, hypotenuse, opposite leg, and adjacent leg. So pause your video while you write these down into your notes. Alright, now that you have these down, we're going to kind of go over a little bit of this information. Here is a mnemonic to help you remember. There are other mnemonics that you might know, like PEMDAS or Please Excuse My Dear Aunt Sally, that we use to help remember different things in math and things that we want to remember. So, some old hippie caught another hippie tripping on apples, where we have the first part here, the second part there, and then the third part. And so what we get out of this is sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And so these are our setups. Just remember that we have the mathematical princess SOHCAHTOA, and that will help you remember those letters. Alright? So, Here we have a question. We want to write the ratio, which is a fraction. We're not going to worry about the decimal for this question. So we look at the sine of d, and here's angle d. I like to circle my angle. And remember that we need our SOHCAHTOA. SOHCAHTOA. So sine is O over H. So my opposite for that angle is the 15. My hypotenuse is 39. Remember that all fractions must be reduced, and I get 5 over 13. Okay, I'm going to do it for cosine of d next. Cosine is adjacent over hypotenuse. Adjacent for angle d is 36. Hypotenuse is 39. And I get 12 over 13 when I reduce it. And finally, I have the tangent of d, which is equal to the opposite over the adjacent, which the opposite of angle d is 15. The adjacent is 36. And I'll reduce this to be 5 over 12. And these are the ratios for those trig answers, those trig functions there. All right, so as we go to the next page, do these three, pause the video, do these three, and then come back and turn the video on and check your answers. All right, so the sine of f, we've changed the angle here. This is now my opposite, my adjacent, and my hypotenuse. So sine is O over H. So you should have here 36 over 39, which is 12 over 13. The cosine of f, which should be 15 over 39, which is 5 over 13. And the tangent of f, which should be opposite over adjacent, which is 36 over 15, which is 12 over 5. And you can check your answers there. All right. On your homework, you'll have to do a trig ratio practice. It'll be a little more complex. So here are some practice problems with that. The first one we look at is the sine of A is equal to, remember that's opposite over hypotenuse. So here's angle A. This is my opposite. This is my adjacent. This is my hypotenuse. So that is 4 square root of 2 all over 2 square root of 14. Remember that we cannot leave radicals like this, so we have to simplify and rationalize this radical. So these cancel. And so what I'm left with is 2 over the square root of 7. Remember, I cannot have a radical in the denominator, so I multiply top and bottom by square root of 7. And I end up with 2 square root of 7 all over 7. All right. So there are 3 others here to do. So pause the video, do the other 3, turn the video back on, and check your answers. All right, so you've turned the video back on. Here are the missing 3 answers. And so the problems can look more complex. When you see a problem that looks like this, remember that because we're dealing with ratios, we want to follow the hint here, which is try converting all the decimals to fractions. So this becomes 1/10. This becomes 6 out of 100, which is equal to 3 out of 50. All right, and then the cosine of t would equal the adjacent over the hypotenuse, which is adjacent to angle t is here. This is adjacent, this is hypotenuse, so 2 over 25 divided by 1 over 10. Remember, there's no such thing as division of fractions, so that's 2 over 25 times 10 over 1. These cancel to get me 4 over 5, which is right there. Now, if you want to pause the video and do the other 2, you can. Pause the video now, turn it back on, and you can see the answers. Okay, if you're checking these last 2 answers, there's that one, and there's that one for you to check with. All right, so to read the trig table, we basically just find the sine of 7 degrees. We're going to find the sine, we're going to find 7. They come together right here, which is that number, 0.1219. We're going to do the tangent of 14. We find tangent. We find 14. They come together right here, which is 0.2493. And then finally, the cosine of 9. Look on the chart. Find it. Check your answer. It should be 0.9877. So these are decimals that represent this when you have it in a problem. So if you have the tangent of 14 degrees, You can take that out of the problem and you can put this decimal in its place. We haven't gotten to a complete problem yet, but we will soon, and you will be able to pull that information off the table and see. The table can also be used to find the matching angle if you have the ratio already. So in this is the sine of theta. Theta is just a Greek letter that represents an unknown angle measure. And so if we look at 0.7986, we look under sine. 7986 is right here. And I can look over, and that means theta is equal to 53 degrees, and there's my angle. Okay. So now if I look up the tangent of theta is 1.3462, I go and I look under tangent, and I look for that decimal. So if that decimal is not there, I have to compare. So 0.3462 is between this one and this one. So it's between those two. And so I'll have to subtract that 1.3462 from both those numbers and see which one has the smaller value. And when I do that, I find out that actually it's closer to theta is equal to 53 degrees. Now there's no fractions on this chart. So for this last one, theta is equal to this fraction. Remember, that's the same thing as 0.6667. So I look under cosine, 0.667. Looks like it's really close to that one right there. And we find out that it's 48 degrees. When we're doing angles, we're going to go to the nearest degree. When we actually go and do the trig problems, we'll do sides to the 4 decimal places usually. I would just read the directions on the worksheet and make sure you follow what they say. Alright, so here's our very first trig problem. In order to work a trig problem, the first thing you must do is label the sides. So if I have this angle here and I label the sides, this is my opposite and this is my hypotenuse. I don't need to label this side here because I don't have anything there. So when I label this and I look back at my SOHCAHTOA there, which one uses O and H? That would be this one. So I know it's going to be the sine of the angle, which is 21 degrees, equals the opposite, which is x, over the hypotenuse, which is 12. There's my setup. I'll ask you on your homework and on your test for what's your setup, and this is what you need to be able to give me. Now we got to finish working the problem. We make this a proportion, cross multiply. X is equal to 12 times the sine of 21 degrees. So that's 12 times. Now you can go into your chart, look up the sine of 21 degrees. That's 0.3584. And then I do 12 times 0.3584, and I get the final answer that 4.3008 is the length of that missing side there. So you got to create your setup. You got to cross multiply and solve your setup. You don't know which trig you're going to use until you label your sides. And this one was a sine. All right, so let's go to our next one. We label our sides. Here's our angle. This is my hypotenuse. This is my adjacent. And so back to SOHCAHTOA, because we're using A and H, that's going to be a cosine. So the cosine of 42 degrees is equal to the adjacent, which is 20, over the hypotenuse, which is x. Again, create a proportion. This would be x times the cosine of 42 degrees is equal to 20. Divide by cosine of 42 degrees on both sides. This cancels, so x is equal to 20 divided by the cosine of 42. And we can look on our chart. Cosine of 42 is 0.7431. And when I divide that, I get x equal to 26.9143. Now remember, back in our last semester, we did an interchanging of the means, but if we did an interchanging of the extremes, couldn't we switch these two out? And then that would take us right from here straight to pretty much here, where I can just go straight to solving my problem. Because the x would come to this position, the cosine of 42 would come down here, and it would be easier to work the problem. All right, our third example, these are trig problems here. This is how they work. We label, here's our angle. We label, this is our opposite, this is our adjacent. If we look at our SOHCAHTOA, the only one that uses opposite and adjacent is tangent. And so then we know the tangent of the angle, which is 63 degrees, equals the opposite, which is x, over the 8, which is the adjacent. Make a proportion, cross multiply. X is equal to 8 times the tangent of 63 degrees. That's 8 times, go look on your chart for the tangent of 63. That's 1.9626. So we multiply these together, and we get x is equal to 15.7008. And that's just one more example, this one using trig, or using tangent. Alright, now our last is our totally different example. And this one here, we're going to use trig, but we're going to use it to find the missing angle. So just like all problems, this is my angle, I label my sides. This is my hypotenuse, this is my adjacent. The only trig function that uses adjacent and hypotenuse is cosine. So I've got the cosine. My angle is unknown this time, and it's 3 over 12, adjacent over hypotenuse. Now, 3 over 12 can be created as a decimal, which is actually 1/4, which is 0.250. So now, just like we did earlier, we go look on the chart. We look for 0.250, or the number closest to it. And what we end up finding out is x is closest to actually 76. So our missing angle here is 76 degrees. And so there are two types of trig problems that we can do. There's ones where we're finding the missing side, or there's where we're finding the missing angle, which is this one. Tomorrow we'll talk about how to do that with the calculator so that we can do all the problems in our calculator instead of using the table. Thanks for listening to the lesson.